Morning, my name is Nita Schmeidler. I manage product management for Morphisec, and today I'd like to talk about proactive prevention, what it is and why I believe it's so important. So let's start by looking at what every security stack really looks like, using the majority of the endpoint security tools, the EPPs. You start with a prevention layer. It's usually built of signatures. It had we used to have in the olden AV days. Then you have some behaviors, some patterns, some machine learning, so you can scan executables pre-execution. You then have a detection layer. This is typically the thickest layer, the largest layer with the most engines. It uses reputation scoring usually for websites, and then it uses machine learning technologies again for a bunch of engines to look for anomalies, to look for things out of the ordinary, and mostly to look for patterns or behaviors that are associated with known types of malwares, with ransomwares, with droppers, and such. It calculates some scores, and if it's still unsure but it's still suspicious, it can send the executable or the file to some sandbox. Then it runs it in a specific environment that can collect additional input. So you end up with a detection layer that generates a lot of telemetry, some severity scoring, and a lot of analysis is needed on top of that. So this layer requires a lot of work on top of the technology. Someone needs to analyze the feeds, the collected telemetry, and come up with some conclusions and some action items. Then you have your remediation layer. That is a remediation and response layer. Remember, again, you detected a breach, now you need to act upon it. You need to maybe quarantine some files, you need to delete executables, you need to do something with the machines. Some actions are automated, others are not automated. You mostly need to contact users or agencies or consumers and report the breach. So a lot of overhead involved in that. You end up with a security stack that requires skilled resources, either in-house or external, in order to manage and configure and analyze it. That means high cost, high risk, and a high mean time to resolution. Okay, so in comes proactive prevention. What we are doing with proactive prevention is we're increasing the level of prevention. We're increasing the layer of prevention in your stack. So we're talking about prevention first and foremost strategy. Now, the real-time prevention gives you zero mean time to resolution since you prevent the attack before it occurs. In addition, using proactive prevention rather than known signatures, known behaviors, known patterns, it allows you to prevent not only the known, but also the unknown. Then when we talk about the detection layer, it can be a slimmer layer because you can use the prevention information as a fidelity filter for the numerous events collected by the detection engines. This allows you to focus on the more important information first and to prioritize your analysis. Next, we have your remediation layer. Still need to remediate anything that you detected. Of course, you do not need to remediate attacks that were prevented post-breach. So how do we actually achieve proactive prevention? What we do is we achieve it using the concept of moving target defense. And what is moving target defense? It's pretty clear in warfare, right? But if we move to non-military examples, say bank robbery, right? Nicer subject, nicer domain. Say someone wants to rob a secret safe in a bank. He has the blueprints for the bank. He comes in with the blueprints, but the safe has been moved to somewhere else. The blueprints are no longer relevant. He cannot find the safe. Again, I think a pretty clear example, but what does that have to do with cybersecurity? So let's look at the Department of Homeland Security, what they stated when they called out for moving target defense cyber solutions. They said, the static nature of computer networks and systems makes them easy to attack and therefore hard to defend. The problem with existing endpoint tools is that they're reactive. And they try to detect each new threat after it's already succeeded in the wild, after it's already known. When defenses are reactive and targets are static, adversaries can always learn how to pass our defenses and achieve their goals. With moving target defense, you can create an environment in which defenses are proactive and the target is therefore unpredictable. So how does that actually work? We're talking about the applications, which are really your attack surface, the way attackers come into the organization. You have your applications running on your endpoints and on your servers. The way the system works is each time an application gets loaded by the operating system into memory, right, as it's going to start running, we do two things. First of all, we morph the application memory structure, and we also create a skeleton, or if you want, a trap or a decoy of the original structure. We then step out of the call stack, the application gets to the main part, it starts running, loading is finished, application starts running, the application behaves as it should, everything is functioning properly. Okay, now all good until an attack comes in. When the attack comes in, it can be any type of attack, right? It can be an exploit-based, evasive malware, it can be a fileless attack, any attack that's going to utilize the memory. Why would it utilize the memory, you may want to ask? The attack needs to do something, right? It needs to run something, it needs to write something, read something, anything that it needs to do, it needs to get to some resources. So what it does, it tries to access the original resources, and now the original resources have been moved, and what is there in their stead is a trap. So two things happen. First of all, the attack is prevented. It can't run. It's been prevented. It's stopped. Second is we collect a lot of valuable information, and we can later use it to report what the attack was, or a lot of information about it. So this is really proactive prevention, right? It doesn't need knowledge. It doesn't use any knowledge. It proactively changes the attack surface so the attack doesn't work. It's deterministic, right? It doesn't use any heuristic, no guesswork, no analysis, and it's resilient. It stops the unknowns of yesterday, the unknowns of today, the unknowns of tomorrow. Okay, let's figure out the next slide. So what can we do with moving target defense in terms of security? Moving target defense has a very broad coverage. Let's look at the attack stages. So when we took a look at attacks, the relevant stages are infiltration, their pre-execution, and their execution. Remember, we're preventing the attack, so so we do that before the malicious action has already occurred. So these are the relevant stages. And let's look at the way attacks come into your organization, into your machines. They either do that using downloads, using web browsing, physically running some processes, or accessing by network. Anything that is done, moving target defense can address, and then it allows preventing in-memory attacks in each of those. And now, if we can look at the various types of attacks this can address, and we can really see the breadth of coverage. We can see that the newest, the most sophisticated attacks, the attacks that you read about in newspapers, and the attacks that you hear bypassing standard solutions, all these attacks can be addressed by this technology. Some examples are ransomware, banking, rats, miners, downloaders, info key stealers, and others. Additional examples that we can look at are exploits, unpatched exploits, right? And fileless attacks are living off the land. Some examples, or a typical example, would be Bluekeep, right? That's a very good example of an exploit that can be addressed by moving target defense. Okay, now to my favorite slide. The reason I like this slide, it really showcases the power of proactive prevention. So let's look at an example of a 0-day. This is a nice 0-day. It's an Apple 0-day. It was an attack that used iTunes. iTunes is a component that's installed on many desktops in order to sync your iPhone with your laptop. It used a very specific component, the Bonjour component, that's part of iTunes, and that component is really never uninstalled. Even when you uninstall iTunes, the component is still there. So we saw that attack, and when I say saw, we stopped this attack at our customer sites beginning of August. Okay, well, first of all, we stopped the attack. Only later, we analyzed the attack and understood what it was. After we analyzed it, we understood it, we of course notified Apple. This is our responsible notification policy. Apple acted immediately, did their own analysis, they created a patch, they published the patch, Articles were published. All this happened until the October timeframe. Then, if you're say you're a diligent organization, you do everything by the book, you're very process oriented, you install patches the moment you get them. So you install the patch October, end of October, beginning of November, then you think, wow, we're really good. The patch came out, we immediately installed it. We're safe. But when we look back at the timeline, the attack was already out in the wild, creating a risk, being active since August. So you have the 3 months gap here is the 3 months where you are not safe, you're not protected, although you did your best. This is why proactive approach would keep you safe from day zero. See, this whole time gap doesn't exist, is covered fully for anyone using the proactive prevention approach. So I think we now understood how the technology works and what the power of it is, and now let's look at several very relevant use cases. So the first one I want to examine is the server use case, server and clouds. If you look at the Gartner pyramid for cloud workload protection, these are the controls that are needed in order to protect your cloud, your server workloads. So we start with the foundational layer, and of course this is a must layer, but you always have it. Moving up to a must-have layer, you can see that the exploit prevention, the memory protection layer is a critical layer. And this layer is addressed by proactive prevention. Proactive prevention gives us exactly this layer. And when you use this layer, you're protected from the following type of attacks. Let's look at them. All very standard server workload-oriented attacks, lateral movement, supply chain attacks, attacks on admins, virtual applications, anything that has to do with unpatched systems, because this technology offers you virtual patching. Again, ransomwares, crypto miners. Additional significant advantage on top of prevention is the way that it's built for servers. There is no CPU consumption, there are no updates needed, as we saw before. You don't need to update anything because there is no knowledge base, there's nothing needed to run this technology. It's autonomous, it doesn't need to connect to anything, it just protects. And of course, it can run anywhere. It can run on-prem, it can run cloud-based, whatever cloud, it can run physical, virtual systems, what have you. Okay, another use case that is very popular now is the remote workforce use case. And I think the majority of us have at least some of our workforce working remotely from home. And, statistics show or research shows this is going to continue for a very long period of time and may change the whole way workforces work. So the many challenges we're all facing, right, is that we have employees working outside of the corporate network. So how are they actually doing that? One option is they took their work desktops home, and the work desktops are configured to run, security-wise, are configured to be working inside the LAN. Do they still have the same security in place? Probably not. Another option is for them to be running their own personal computers. No one is really sure what's really installed there, right? It's their personal computers. Some organizations start a very large-scale VDI deployment. Again, this comes with its own challenges of protecting VDIs, because VDIs are susceptible to the same attacks as regular desktops, right? Sometimes even more so because they're already on the server. Another challenge that we face is the increase in using remote workforce applications. We all read about that, no need to get into that, but that's an additional challenge. And you have your security team, and now that it's decentralized, all spread out. Are all your security processes still working as before? Sometimes less, right? So all these challenges, proactive prevention can help you with. It works very well with offline. It doesn't need anything to be connected. It provides you virtual protection, virtual patching. It does virtual application hardening. Again, as we said, it works both for VDIs and for physical machines. Very, very easy to roll out. You install it. It's a very slim agent, nothing much to do. And there's nothing to manage, nothing to configure, right? Nothing to analyze, because as we said, there is no knowledge base, there's no database, no repositories, so nothing to do about that. A very important factor here is the data collection. There is no telemetry being collected. There's no personal information. There's no data being constantly collected. So all your privacy concerns, all your end user privacy concerns really are addressed by that. And this provides you just deterministic prevention. Another nice aspect of it is that it does so without hindering productivity, right? Your business users can continue working, can continue always running. Breaches, attacks are addressed before they happen. Business functions as usual. So now that we've discussed the technology and the use cases, let's just see for a second why it's strategically different from the standard security stack. So let's look at the following parameters. We have the time that it takes, we have the attack vectors, simplicity, and finally the roll-up of all these to ROI. So in terms of time, when we look at reactive technologies, they act post-breach, right? The breach has already happened, you need to address that. Whereas when you look at proactive prevention, it's pre-breach, it's instantaneous, attack is stopped, and that's it. When we look at attack vectors, reactive technologies are more oriented towards malware and are, of course, far less oriented towards unknowns or anything that is not very similar to known attacks. Whereas proactive technology, that's the real strength, right? It can protect you from the unknowns of yesterday, the unknowns of today, the unknowns of tomorrow. Next, we have simplicity in terms of what you need to do, what you need to configure, how much you need to act upon it, what you need to analyze, how skilled you need to be as a security, as a forensic professional. You need all this for reactive technologies. You don't need it for proactive, because proactive did the work for you, stopped the attack. You need to read the reports, of course. You need to understand what happened in your organization, what you need to look for. But the attack was already prevented. So when we roll all that up into ROI, we have for reactive higher total cost of ownership, whereas for proactive we have low total cost of ownership, and we have much better productivity, much less, many less, I guess, patches than you have on the reactive side. To summarize, proactive prevention reduces your risk. It prevents attacks that are widespread and can bypass other solutions, right? And we look again, we talk about the Fileless, the exploit base, the evasive malware, and especially the 0 days. When we talk about operational savings, again, we have the rapid time to value, we have the very simple operations, we have the smaller, simpler stack, and we have less people, less experienced, less skilled people needing to manage it. And again, no less important, we have the ability to allow the business to focus on business, concentrate on business, and do their business. Productivity is a very important factor in proactive prevention. So who are we? We're Morphisec. We are installed on over 5 million systems, endpoints, servers, various categories of customers. We have various industries, healthcare, financial, manufacturing, shipping, software, what have you. And we offer proactive prevention of the most dangerous cyber attacks for your endpoints, for your servers, for your cloud. You can come look us up at the Azure Marketplace. Thank you very much.